This is section 9.4 of Algebra 1. It's a continuation of 9.3. We learned the beginning step of the complete the square method, and now we're going to see the entire effect where we can actually solve for x using this method. Now remember, this applies to quadratic equations that aren't factorable. However, many times the problem they give you will be factorable. But if you're called on to use complete the square method, don't factor. Always use the required method. That's what gets you the credit. Okay, so some of these can be solved by multiple means. You always want to be reading your instructions and doing what's appropriate. Now you got a lot of steps on page 318. Okay, first we're going to simplify the equation to the form ax squared plus bx equal negative c. Remember in the last video I mentioned we're separating the unknown values from the known value, or the constant. So we basically want all our x's here and our constant there. So we're going to have to add 7 to both sides. We will end up with x squared plus 4x is equal to 7. Now it's a good idea, now that we have the equal sign here, if you leave a gap here. We're going to fill in a blank just like we did before, because yesterday we worked only with this amount, this side, and now we're going to do the entire thing. So just like we did before, step 2 tells us to divide both sides by a, so we get a quadratic coefficient of 1. We've already got that, okay? We'll demonstrate that in just a minute. So step 3 tells us to square half the linear term. So just like we did before, we're going to take the 4, divide it by 2, and square it, which gives us 2 squared, or 4. And just like before, then we're going to add this 4 here, but now we've got an entire equation, and I cannot simply change the left-hand side of the equation without doing the same thing on the right-hand side. So since I added 4 here, I must add 4 on this side. So we've taken half the linear term, we've squared it, we've added it to both sides. Now, many textbooks will tell you to put 2 squared here and 4 here. Now that's a good idea because it helps us factor on this side. So it doesn't matter, whatever's comfortable for you. I learned by putting the 4 on both sides, and so that's usually what I revert to. But if it's helpful to you to put 2 squared here instead, then by all means do that. Okay, so now that we have these values where they go, we're going to factor on the left. Square root of x squared is x. Square root of 4 is 2. We're going to use the sign of the linear term and square it. And over here, we're simply going to add our 7 and our 4 to get 11. Now, from this point on, you're using the extract the root method. So this is something you've already learned as well. So there's very little here that's new, except maybe how to put the answer together. So I have a square here and a constant there. We're going to take the square root of both sides. This will be step 5 in your steps on page 318. When I take the square root of a squared value, I simply get the radicand out. And over here, when I take the square root of a constant, I have to remember to put plus or minus in because I'm in an equation. So this is equal to plus or minus the square root of 11. It's not a perfect square and it's not factorable, so we're going to stick with that. Now my goal here, and they don't really have a separate step for it because this is all involved in extracting the root, is just to solve for x. So I want x by itself, so we're going to subtract 2. X is equal to, always put this in front of the plus or minus sign. If you put it behind, it gets confusing, especially if the little tail on your square root gets too long, you forget what's under and what's not. So here I actually have 2 different values. I have negative 2 plus the square root of 11, and I have negative 2 minus the square root of 11. It's 2 separate answers because that's generally what we get when we factor a quadratic. It's a second power equation resulting in 2 solutions. Now here we do not have to do this. We do not need to separate it out. We just need to be aware of what it represents. So this is good for the answer here. Now we should substitute it back in and check, and you know how to check your equations. So by all means, check each one. Check it like this, and then check it like that. Don't try to check it all the way through all at once. Okay, now I want to work a couple that have a different type of appearance in the solution. So let's work about 2 more samples, and then that's all I'll do today here. If we have x squared plus 5x minus 6 equals 0. Now most of you can look at that and you know right away that it's factorable. We did this one a whole lot of times. Okay, but we still want to use this method, but you're going to see in a little bit how that impacts the type of solution that we have. So step 1, we want to separate our unknowns from our knowns. So we're going to add 6 to both sides, giving x squared plus 5x is equal to 6. Again, notice I left myself a little blank there because we're going to play fill in the blanks. We're going to take half the linear term, okay, 5 halves. We're going to square it. Now some of you may just want to go ahead and put this right up in there. That's okay if you do. This gives me 25 fourths. So I'm going to add 25 fourths to both sides. All right, half the linear term, squared it. We're going to add it to both sides. All right, now we're ready to factor on the left, just like before. Square root of x squared, square root of 25 fourths, sine of the linear term. It's squared because a perfect square trinomial gives us a binomial squared. Now we have to be careful over here. I've got 6 and I've got 25 fourths. I need a common denominator. So we're going to change 6 to 24 over 4. Okay? In case you don't remember how to do that, 6 over 1, I want to change it to fourths. So I multiply by 4 on the bottom. I have to multiply by 4 on the top. Gives me 24 fourths. So 24 fourths plus 25 fourths gives me 49 fourths. All right. Over here, just like before, we're taking the square root of both sides. We have plus or minus. Don't forget your plus or minus. That's what gives you your two results. Taking the square root of a squared value gives x plus 5 halves is equal to, over here, now, the square root of 49 fourths, the square root of 49 is 7, the square root of 4 is 2, and I have plus or minus. So notice here it came out from underneath the radical. It was a perfect square. We want to isolate x, so we're going to subtract our 5 halves, giving x is equal to, again, put this one first, negative 5 halves plus or minus 7 halves. I have two fractions. This is math that I know how to do. On the last one, we had a whole number and a radical. Basically, we have a rational and irrational value. They cannot be combined with addition or subtraction. But here we can do this math. So we have two different ideas. Negative 5 halves plus 7 halves and negative 5 halves minus 7 halves because of this plus or minus here. Now here our signs are different, so we want to subtract, give the sign of the larger. We're going to have 2 halves or 1. Here the signs are the same, so we're going to add and keep the sign. So negative 12 halves gives us negative 6. So my two solutions here will be x equal 1 or x equal negative 6, and each one of those values can be checked. So you can see sometimes we're going to come all the way down to whole numbers. Don't, in this case, do not leave your plus or minus. Okay, it's not acceptable there because it's math that we know how to do. Sometimes students forget to do the final step here when we don't have radicals. All right. If you'll look real quickly on page 319 down at 9.4c, this example is what's being referred to in the original list of steps in step 2. It says to divide both sides by a, so the quadratic coefficient is 1. Now I've talked about that quite a bit in my notes that I sent home. The quadratic, or the complete the square method only works when this value is 1, and it has been in the last two problems. But if you look at the bottom of page 319, 9.4c, you'll see that you have a 2 for the leading coefficient. Because of that, you're simply going to have to divide through by 2, making it 1 before you can ever start. So I have 2x squared minus 5x plus 2 equals 0. Before I can begin, I'm going to have to divide through by 2, getting me x squared minus 5 halves x plus 1 is equal to 0. And then we can proceed like before, okay? Isolating our x's bringing our constant over here. Now here we saw this yesterday. If I already have 5 halves, rather than taking half or dividing by 2, it's easier to multiply by 1/2 and then square it. And you can follow the rest of that one through. It's not significantly different after we do this step, but always remember, never try complete the square method unless you have 1 for your quadratic coefficient. Okay, so that's pretty much gives us, I think, what we need. You have everything else in your packets and in your textbook. If you need further help, send me a message, my school works, and I'll try to work with you a little bit further on it. Okay, thank you.